Hello everyone, I'm Ploychompoo Polrom. Today I'm going to talk about quantum computing, which is the future trends of technology. And what is quantum computing? Quantum computing harnesses the phenomena of quantum mechanics to deliver a huge leap forward in computation to solve current problems. IBM, who is the first company, designed quantum computers to solve complex problems that today's most powerful supercomputers cannot solve and never will. Why quantum computers are faster? For over 2 decades, IBM has been pioneering the development of quantum computer systems to solve these sort of problems in fundamentally new ways, making use of these two approaches. Quantum computers can create vast multidimensional spaces in which to represent these very large problems. Classical supercomputers cannot do this. Algorithms that employ quantum wave interface are then used to find solutions in this space and translate them back into forms we can use and understand. Here is the process. The first one is activate the spread, second is encode the problem, and the last one is unleash the power. One promising quantum algorithms that use these techniques is called group search. Suppose you need to find one item from a list of n items. On a classical computer, you would have to check n divided by 2 items on average. And in the worst case, you would have to check all n. In a classical computer, they may execute for 1 week, but in quantum computer, they may execute by 1 second. Only 1 second. And why do we need quantum computers? Until now, we have relied on supercomputers to solve most problems. These are very large classical computers with thousands of classical CPU and GPU cores. However, supercomputers are not very good at solving certain types of problems, which seems easy at first glance. This is why we need quantum computers. For some problems, supercomputers are not that super. Imagine you want to seat 10 fuzzy people at a dinner party where there is only one optimal seating plan out of all the different possible combinations. How many different combinations would you have to explore to find optimal? And here, if we have 2 people, we can have a total combination is 2. You can calculate by use n factorial. And if we have 5 people, the total combination is 120. That's much, right? But if we have 10 people, can you imagine? The total combination is over 3 million. Only set 10 people to sit around the table. Larger versions of these kinds of problems stump our most powerful supercomputers because the first is supercomputers don't have the working memory to hold the myriad combinations of real-world problems. And the second is supercomputers have to analyze each combination one after another, which can take a long time. Here are some simple examples of these combinatorial optimization problems. A logistic company delivering to 50 cities want to know the optimal route to save on fuel cost. An investment company want to balance risks of their investment portfolios. And a pharmaceutical company want to stimulate molecules to better understand drug interactions. Maya quantum computer are used. Since 2017, IBM and other companies has been working with to solve problems like these. Here are real-life quantum computing applications. A new generation of electric vehicle through quantum battery technology. Reducing atmospheric carbon emissions using quantum computing added material discovery. Or searching for Higgs events and the origin of the universe. Or exploring quantum computing use cases for healthcare such as diagnostic assistance, precision medicine, or optimize insurance premiums. Quantum computing in this time and in the future. Quantum computing that big companies are investing in quantum technology has progressed from a research experiment to a tool on the brink of transforming a variety of industry. Here is the graph that shows that forecast size of quantum computing market size in the worldwide during 2019 to 2029. You can see the graph have the increase gradually for the 5 to 10 years in the future. Companies like Microsoft, Google, Intel, or IBM are racing to build quantum computing tools. From many informations and my opinion, quantum computing is still hard to understand in terms of physics. At the present, some problems still unable to be solved or still have many mistakes. For example is stabilizing the qubits in a system. But in the future of 5 to 10 years, these problems are probably solved and fixed. When that day becomes, the quantum computing will be the greatest future technology for surely. And thank you for your attention and hope you enjoy my slide.